For subtraction of functions, we have f minus g of x, which is simply f of x minus g of x. And again, our domain is where the domain of our f function and the domain of our g function intersect. For example, f of x equals x squared plus 1 and g of x equals x plus 2. F minus g of x is simply f of x minus g of x. Here's f of x minus g of x. Distribute out the negative to both of those, and you'll get x squared minus x, and a 1 plus a negative 2 is negative 1. What's our domain? Well, where do these overlap, or where do they have an intersection? They're both all real numbers, so they will intersect at all real numbers. For multiplication of functions, we have f times g of x, which is simply f of x times g of x. What's this domain? It's where the intersection of the domain of f and the intersection of the domain of g are found. For example, f of x equals x squared and g of x equals x plus 1. F times g of x is f of x times g of x. F of x times g of x, distribute out, you get x cubed plus x. What's this domain? Well, the domain of f and the domain of g are both all real numbers, so our domain of the composite function will be all real numbers. And finally, we have a rule for division, f of x divided by g of x. Our stipulation is that the denominator, g of x, cannot equal 0. So our domain of f of x divided by g of x is the intersection of f of x domain and g of x domain, with the exception, that backward slash means except where g of x equals 0. For example, if f of x equals x squared plus 6x plus 5 and g of x equals x plus 1, f of x over g of x is x squared plus 6x plus 5 divided by x plus 1. When you divide this into this, either by synthetic division or long division, you get the other factor, x plus 5. It's true that x plus 5 times x plus 1 gives you x squared plus 6x plus 5. What's the domain? Well, it's the intersection of the domains of the f function and the g function, which is all reals with the exception of x cannot equal negative 1 because our denominator, x plus 1, cannot equal 0. X plus 1 can't equal 0, so x cannot equal negative 1.